(7.1) Acids and bases. Learning outcomes for this subtopic are: define buffer solution, describe how a buffer solution controls its pH, and write the Henderson-Hasselbalch equation for a given buffer solution. What is buffer solution? Buffer solution is a solution which is able to maintain its pH when a small amount of strong acid or strong base is added to the solution. The components of the buffer solution are weak acid and its conjugate base, or weak base and its conjugate acid, which will then results in the formation of two types of buffer solution: acidic buffer solution and basic buffer solution. Alright, now we're gonna look at acidic buffer solution first. Acidic buffer solution can be prepared by mixing a weak acid and its conjugate base. In this example, we use acetic acid and its salt, sodium ethanate. The reactions that occur in the buffer solution can be represented by dissociation equation of acetic acid and sodium ethanate. Note that we have two different arrows here, reversible and single arrows. Reversible arrow indicates partially dissociated while single arrow indicates completely dissociated. Hence, the amount of conjugate base in the solution is mainly from the complete dissociation of salt. How an acidic buffer solution acts. In a beaker, we have a weak acid and its conjugate base. What will happen when a small amount of strong acid is added? The conjugate base will consume the acid, where we can write the equation as a result, there will be a small change in pH, because the concentration of conjugate base has decreased, and concentration of weak acid has increased. Next, what will happen when a small amount of strong base is added? The acid will consume the base, where we can write the equation as a result, there will be a small change in pH, because the concentration of conjugate base has increased, and concentration of weak acid has decreased. Now, let's have a look at basic buffer solution. Basic buffer solution can be prepared by mixing a weak base and its conjugate acid. For example, we have ammonia and its salt, ammonium chloride. The reactions that occur in the buffer solution are as follows. As mentioned before, reversible arrow indicates partially dissociated while single arrow indicates completely dissociated. Therefore, the amount of conjugate acid in the solution is mainly from the complete dissociation of salt. How the basic buffer solution acts. In a beaker, we have a weak base and its conjugate acid. When a small amount of strong base is added, what will happen is, the conjugate acid will consume the base. As a result, there will be a small change in pH, because the concentration of weak base has increased, and concentration of conjugate acid has decreased. Next, when a small amount of strong acid is added, what will happen is, the weak base will consume the acid. As a result, there will be a small change in pH, because the concentration of weak base has decreased, and concentration of conjugate acid has increased. Finally, we can calculate the small changes in pH by using the formula called Henderson-Hasselbalch equation. There are two equations. The first equation is used for acidic buffer solution, and the second one is for basic buffer solution.